VILTER's single screw compressor, the inside story. In the mid-1980s, VILTER decided to build its own screw compressor and became a licensee to fabricate both twin and single screw compressors. In evaluating both technologies, many inherent benefits of the single screw were recognized. Thus, VILTER decided to produce single screw compressors. To this date, with thousands of compressors operating in the field, VILTER's team members are confident that they made the right choice in screw compressor technologies. A single screw compressor unit is comprised of typical components including an oil separator, lubrication pump and piping, an oil cooler, oil filter, microcontroller, suction stop check valve strainer assembly, a motor whose shaft is connected by a coupling to a compressor. This presentation focuses on the compressor. Looking through the side access cover, at the core of the single screw compressor is a single main rotor. Let's take a look at the compressor from the other side. By removing the front housing, the motor coupling, the suction inlet on the top, and the two side access covers, we see the bare frame of the compressor. Removing the pair of capacity slide valves, the pair of volume ratio slide valves, the two Stargate rotors, and sliding back the casing, we reveal the heart of the compressor. The main rotor of the single screw compressor is a simple cylinder with a shaft through it. There are 6 threads, or grooves, or flutes cut in the cylinder. Each flute is opened at one end of the cylinder, diminishing to 0 volume out the side of the cylinder before reaching the opposite end. The opened end of the grooves allows low-pressure suction gas to fill the flutes. In operation, each flute becomes a compression chamber. Looking down the shaft from the suction end of the compressor, you'll notice 4 holes drilled through the main rotor. These vent holes allow the cavity on the opposite end of the rotor to also be at low suction pressure. Depending on the size of the compressor, there are either 2, 4, or 6 vent holes drilled through the main rotor. The main rotor rotates on the shaft typically at 3600 revolutions per minute, yet with some models at half speed or 1800 RPM. 2 Stargate rotors intermesh with the main rotor. The Stargate rotors are identical in shape and are positioned opposite of each other across the diameter of the main rotor. While the main rotor rotates, the Stargate rotors go along for the ride. As the tooth of the gate rotor intermeshes with the flute of the main rotor, the tooth serves to close the gate, trapping the gas in the flute. As the tooth travels through the flute, the trapped gas is compressed to a smaller volume and higher pressure. With 6 total flutes, 3 flutes are engaged in compression on the top half of the compressor, and the opposing 3 flutes are simultaneously engaged in compression on the bottom half of the compressor. The gate rotor on the opposite side is oriented identically to the gate rotor on the near side, just flipped over. The gas that enters the flutes on the top half of the compressor is compressed by the gate rotor on the near side, and the gas that enters the flutes on the bottom half of the compressor is compressed by the opposing gate rotor on the far side. A casing wrapped around the main rotor encloses and traps the gas in the flutes. In this case, we show a fixed port casing with a fixed triangular-shaped discharge port. High-pressure compressed gas is discharged from the casing's triangular ports out the side of the compressor. The blue cloud at the right end of the main rotor represents the low pressure of suction gas. The vent holes drilled through the main rotor allow the same low pressure condition to exist in the cavity at the left end of the main rotor. The pressure of the suction gas exerts a force in an axial direction on the main rotor. But since suction pressure resides at both ends of the main rotor, the axial forces cancel, resulting in a 0 net axial force on the main rotor of the compressor. Rotating the compressor to an axial view, we see that the compressed gas is discharged simultaneously from 2 opposing discharge ports out opposite sides of the compressor. The radial forces exerted on the top of the compressor are identical and opposed to the radial forces exerted on the bottom of the compressor. Thus, the radial forces cancel. Both axial and radial forces are canceled. The only net force on the main rotor of the single screw compressor is gravity. The low bearing loads result in extremely long compressor life and very high reliability. The VILTER single screw compressor is the only industrial refrigeration screw compressor offered with a standard 15-year bearing warranty. Now let's look at capacity and volume control. A fixed port casing wrapped around the main rotor would be similar to the casing of an air compressor, where a fixed volume of gas is trapped, compressed, and discharged out of the fixed port. Here we see a Chicago Pneumatics fixed port air compressor with a split casing. Looking at the suction end of the air compressor with the top half of the casing lifted, notice the triangular shaped discharge port in the casing through which the compressed gas is discharged. The VILTER single screw compressor does not have a fixed port casing. Rather, a portion of the casing is removed from both sides of the single screw's frame. The portions of the frame that were removed are replaced with two bars of steel, or slide valves, on each side of the compressor. The patented Parallax slide valves retain the curved shape of the casing they replaced. Looking at the casing of a VILTER single screw compressor, notice the voids in the frame that accommodate the parallel slide valves. The slide valves are supported by carriage assemblies, which are mounted in the compressor's frame. Each slide valve is able to move or slide in the direction of the axis of the main rotor. The position of the right edge of the capacity slide valves, shown in yellow, determines the amount of gas that is trapped and compressed. The infinitely variable capacity slide valves are capable of modulating from full load, when positioned to the right, to 10% of full load when positioned to the left. The position of the left edge of the volume ratio slide valves, shown in green, determines the pressure or volume at which the gas is released from the compressor. The volume slide valve enables infinitely variable volume ratio control from a low 1.2 VI when positioned to the right to as high as 7.0 VI when positioned to the left, the broadest volume ratio range in the industry. The parallel slide valves are interlinked so that the position of the capacity slide valve on one side of the compressor is identical to the position of the capacity slide valve on the opposite side of the compressor. Likewise, the position of the volume ratio slide valves is identical on both sides of the compressor. Thus, the Parallax slide valve design maintains the balanced forces around the main rotor of the compressor. The capacity and volume ratio slide valves are positioned in parallel to each other, not in series. With the single screw slide valves, there are no slide stops or mechanical limitations to restrict their functionality. Both slide valves are able to modulate within their full range of travel simultaneously. Thus, the VILTER single screw is the only industrial screw compressor capable of operating at optimized efficiency through its full capacity range. So far, we've presented the two primary benefits of VILTER's single screw compressor: balanced forces for extremely long bearing life and high reliability, and the Parallax slide valves for optimized efficiency through its full capacity range. Besides these primary benefits, there are also many additional benefits of the single screw compressor. All of the single screw compressor's bearings are at suction pressure. With the single screw, there is no risk of bearing degradation or failure due to liquid ammonia washing oil off the bearings in the discharge gas stream, since there are no bearings in the discharge gas stream. This feature of the single screw allows the success of VILTER's cool compression technology. Further, lubrication of the bearings is easily achieved due to the high differential pressure between the oil that's fed to the bearings and the low pressure at which the bearings operate. The single screw's length to diameter ratio, or the L/D of the rotors, is proportional. The single screw's rotors are stocky and rugged, and their L/D proportions remain consistent throughout the entire product line. The robust construction of single screw rotors is not subject to the challenges presented by mid-rotor deflection of other technologies. With the single screw, cascading is minimal. Cascading is when gas slips across the land from a high-pressure flute to the adjacent lower-pressure flute. The land, which separates the flutes, is shown here in green. The land of the single screw is not a sealing tip, but rather a flat, wide surface. Notice how, as the rotor rotates and pressure increases, the land increases in width and cascading is minimized. Minimal cascading results in high volumetric efficiency. The single screw's gate rotors are constructed of a non-wearing, high-performance engineered composite material having a chemical composition polyphenylene sulfide, or PPS, and is commonly known as Riton by its producer, Phillips Chemical Company. This material is incredibly strong. Some characteristics of Riton include high temperature stability, dimensional reliability, and flame retardance. Riton holds up to any gas or liquid. In fact, it has such high chemical resistance that there are no known solvents of Riton below 400 degrees Fahrenheit. The gate rotors are tolerant of extreme conditions. This gate rotor took the hit of 1,160 foot-pounds of energy from an AK-47 rifle at 50 yards. Notice that where the bullet hit, the inflicted damage did not extend beyond a 3/4 inch diameter hole. The gate rotors are tooled to conformance by the main rotor. There is no need for match marking or mating pairs of rotors with the single screw compressor. Gate rotors are easy to access and replace if necessary right through the side access covers of the compressor without removing the compressor from the unit. Replacement of the gate rotors restores the compressor to original capacity. The single screw compressor is quiet and vibration free. Here we see a single screw unit in operation with a nickel unsupported and standing on its edge on the top of the compressor's housing. It's quiet and vibration free primarily due to its balanced design and the flow of its discharge gas pulsations. Consider the gas pulsations of 3 different compressors operating at 3,600 revolutions per minute. A 4-load twin-screw compressor produces 4 discharge gas pulsations per revolution, times 3,600 revolutions per minute, or 14,400 gas pulsations per minute discharged from a single port. A 5-load twin-screw compressor produces 18,000 gas pulsations per minute discharged from a single port. A single screw, with its 6 flutes and 2 discharge ports, produces 12 discharge gas pulsations per revolution, or 43,200 gas pulsations per minute discharged simultaneously from dual opposing discharge ports. As a small volume of gas is discharged from one port, a simultaneous small volume of gas is discharged from the opposing discharge port. Any induced vibration to the frame of the compressor due to a discharge pulse on one side is cancelled by the identical volume discharge pulse on the opposite side. It's very unusual for vibration monitoring and analysis to be applied to a single screw compressor because the single screw is inherently a vibration-free compressor. In summary, the single screw compressor's balanced forces provide an extremely long life and very low maintenance. Its parallel slide valves result in peak energy efficiency. All of the compressor's bearings are at suction pressure for reliability. The length over diameter is proportional throughout the product line. The land is wide for minimal cascading and high volumetric efficiency. Gate rotors are durable yet forgiving. It's a quiet and vibration-free compressor, and the single screw is the only screw compressor unit with a 5-year compressor and 15-year bearing warranty. The single screw product line consists of 2 series of units, the VSM with 9 models ranging from 150 CFM up to 700 CFM, and the larger VSS units with 11 models ranging from 750 CFM up to 3,000 CFM. These units are built around 6 different rotors, from the smallest 205 mm rotor, about 8 inches in diameter, up to the large 395 mm rotor, which is nearly 16 inches in diameter. The 205 mm rotor provides us with 6 models, from the VSM 152 up to the VSM 401. The model number indicates the compressor's capacity in CFM. The 3 smallest models run at 1,800 RPM, and all of the larger models operate at 3,600 RPM. From the 240 mm rotor, we get 3 models, the VSM 501, 601, and 701. Multiple models are achieved by cutting the flutes of the rotor to varying depths. With the 280mm rotor, we shift to the VSS series of units to get two models, the VSS 751 and VSS 901. We attain models VSS 1051 and VSS 1201 from the 310mm rotor. With a 350mm rotor, we offer models VSS 1501, the VSS 1801, and the soon-to-be-released model VSS 2101. Also pending release are four models built around the largest 395mm single-screw rotor, the VSS 2401, the VSS 2601, the VSS 2801, and the very large VSS 3001. Prototypes for the five largest models will be out this fall.